as we move forward. See you. Thank you.
Okay, then in the absence of any questions or comments, we can start. So may I also remind us all that this class is meant to be interactive. We are supposed to gain all that we can gain from this interaction. So feel free to stop me at any point, make your comments, ask questions, so that is the way to learn fast. So I'm really hoping to get to a time when we can leave this basic R, because R is enjoyable when you get to the complex parts. That's where it can be crazy, really. Just like a follow up to the last question about why R for a neuroscientist or an anatomist, R gets to make more sense when you have big data. That is where other applications may be limited. But R is quite robust, that you can deal with very big data and graphical data, genetic data, just minutes. R has responded to deal with all the data. So today we start with logical operations. So I need us to understand how R works in terms of true or false. True or false may seem simple, but by the time you get into some complex coding where you need a lot of true false to get through things, you need to really maximize it, really get some things done. So like now in line 52, you can see this is what was commanded R. 4, it's equals to sign 4. So this is simply asking simply asking R. Is the object on the left-hand side equal to the object in the right-hand side? So for what I'm saying here, this is simply asking R, is 4 equals to 4? So let's see what R will answer. So I will just click anywhere on this line and then click run. So you can see R had told us true. That's true, yes. 4 is what equals to 4. So now let's run line 53. We're now asking R, is 4 equals to 5? So of course we expect R to return a false, which of course it has returned. So that is just basically about logical operations. True, false, question.
Sorry, Dr. Yanni, can you hear me? Sorry to just interrupt.
Yes, I can hear you. Yes, please go ahead.
I don't know if it's my ears. Is that the loudest you were? I think you were louder than this last week. You seem a bit muffled somehow.
Okay. I don't know. Can I get a confirmation from any other participants? Is my audio poor? Miss Mama, are you there? I think you're not in this place. Can you confirm if my audio is poor?
I think it's clear, sir.
Okay.
Oh yeah. You should also is not here too. Okay, that's true. I think it might be a network thing because we are still on Starlink, which we are enjoying, so to say. So I believe Starlink should be clear. Sorry, Dr. Basa. I think it might be network too. I'm using an earpiece so that my mouth is very close to the microphone. Sorry. All right.
So then another question. So when you want to start asking our logic questions, you just need to impute this line 51, right?
Let me understand your question. Like you can ask R you can have any command in R. R understands its commands when
so it's not compulsory for you to this line 51 is the purpose because you are teaching us. You are trying to demarcate the sections you are teaching us, right?
Yes, this right?
Yes.
Yes. Remember I thought about the hash key. The hash. So once you put any hash, R doesn't read that as a command. It reads that as a comment. So,
Okay.
yes.
Okay. All right. Okay. Thank you.
That's why even in line 52, yeah, you can see from here there's a hash. So from here, I should see it as a comment. So even if I type any command here, I will not execute that. It will execute what is asked, what is in its own environment without the hash. Okay.
Thank you.
All right. Okay. All right. Welcome. So line 54. So here we are now making it a bit more complex. No longer direct this equals this. We're now asking R is 4 equals to this expression 3 plus 1. Of course, R will first compute this. Of course, we know that this is 4. So of course, we expect this to bring out true. So if we now run this, of course, it has come out to be true. And then this is also another logical expression. This is now less than or equals to. So we're now asking R if the object on the left hand side less than or equals to 4, then we want it, of course, it should be true because we know that 3 is less than but not equals to. So either less or equals to. I think that this should have been changed to or less or equals to. That's an error on this part. So that's the logic. Then this one is the greater than sign. Is now asking R is 5 greater than this expression, which is 2 times 2. So if we run that, that will be true because 2 times 2 is 4. So 5 is of course greater than 4. Then this is 5 greater than 2 plus 3, which is 5. Of course, this will be true. Or rather, sorry, false. 3 plus 2 is 5. So sorry, asking R if 5 is greater than, of course, it's false because 5 is equals to and not greater than. So that's why it came out as false. Now, we are going to another one, which is negation. Negation logic. So this, you need to understand this because this can be confusing. But whenever you see this sign, this is in our normal English language, we call it the exclamation sign. But in R, that is the negation sign. So we're not telling R is 4 equals to 3. Return the opposite. So understand this. This is the equal to sign. But this is now give me the opposite sign. So if like now I know that 3 is not equal to 4. But rather the opposite of true is false. Opposite of false is true. So like if I now tell R, give me the opposite of whatever it is that this sign tells me. So now this is now like saying give me the opposite of 4 if b equals to 3. Or rather put it another way. Is 4 equals to 3? Give me the opposite answer. Of course, this will now return as true. You see, it's true. But we know that now. Let me do the command on this side. If I bring this back now, then I remove that negation sign and put the equality sign. This will be false. But because I put the negation sign, as we saw in the previous one, it will be false. So this like negates whatever is supposed to bring out. So if we run line 60, this, of course, ordinarily it should be true, but line 60 will bring out false, which we have seen. Now here too, this will not be true for line 61 because it negates it. So this will now bring up true. So there are instances where you would need to negate. Let me bring this up a bit so that it will let not appear so basic. Let me look for an instance where we might need this. Okay, where can we? I'm trying to. Okay, let me see if I can find an instance where I may have used negation. Even though it's as if we're trying to jump, but I feel once in a while it's good to jump a bit, just for us to have a little feel of its usage while coding.
Please, this is very important. Let's see the application at least.
All right. Okay. I'm trying to check. This is lines of codes I used to analyze the Drosso work we did at Kaba. I remember, I think I used negation at some point. Trying to find, let me expand this so that I'll be able to pass through faster.
Don't you have a search option in R?
Oh, that's correct. Thank you for that. I had just kept my mind. I'll just copy that sign and type it. And I'll just press, like now, I'll just click on my script and press Ctrl F. Then I'll just paste it. And okay, good. So you can see here, line 9 and line 10. I used the negation. In fact, okay, only in line 9. In line 9, okay, to explain this, because I saved this in an object called gr1, and there's also another called Drosso2. Okay, so okay, let me explain what is happening in line 9. Okay, um, there is an other object called Drosso2, which is in line 6. So there is a file which I read into R, which contains data that I want to analyze. So it was a CSV format, and I used this read.csv to upload it to R, and I saved it in R as this object called Drosso2. Uh, Drosso2, this is how the Drosso2 looks like. Let me show you. I've just clicked it, and that's same as typing this command view, the object. So this is how the thing is like. It has that's 12, sorry, it has 7 columns, and 377 rows. So you can see the column 1, 2, 3, 4, 5, 6, 7, and 377 rows. So let's go to the end. 377. So that is what is written here in the summary of it. So this is what is in Doso 2. Okay. Now, I want to create another object called gr1. And I told in this command now, it's telling me, it's telling R now, in this Doso 2 file, I want you to bring out all the rows that 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 the Doso 2 dollar sample. What I mean by the sample is that there is a row, there is a column called sample. Okay, now if you look at sample, sample has many things. Sample has FCT, HF, GM, AF, MCT, and all these things. Now I'm telling R in this command that create this object gr1, but remove anything that has FCT and that has MCT. I don't want them to be in this new object I want to create. So remove all of FCT and remove all of MCT. I only want the other ones to be there. So now if I run this command now, for instance, now I now have gr1. If I check gr1, you can see gr1, you won't see any FCT or any MCT in this. So anywhere there's FCT, I would delete the entire row. Anywhere there's MCT, I would delete the entire row. So far I here now, it has only 335 entries, unlike here that has 277. So I have deleted the rows I specified. So that is where this this command becomes useful. So you want to analyze just a subset of data. So you can give such a command, and until you remove that one, and you do what you want to do. So that is where negation sign can become useful. Okay. So let's continue. Okay, yes.
Okay, yeah, I want to ask a question. I saw those data and I can see 377 rows. I'm just curious. Did you enter them? How did you come about them? Is it that you you type them in Excel and you brought them here? How did you get them into R?
All right. Yeah, that's a great question as well. In R, every R coder, based on how you learn R or how you want to analyze your data or how you want to go about it, you decide how you want your data to be. That was not how the data came in. The data, I think it came in a wider format. I now converted it to a shorter format. So let me check. Okay, this is analysis two. Let me take my analysis one. Um, this is analysis two. Let me bring up analysis one. A minute. Uh, you won't see what I'm doing because I'm only sharing the R screen. Okay. So I'm about opening a new script where I think I may have done some data modification. So I think that may help. Okay, this is it. I want to see where I may have saved that analysis to. Uh, there is one function I want to show you how one can modify one's data to be long. There's something called long data because that's how I actually use to analyze my data. I like making them long. It's easier to work with in that manner.
Okay, so what you are saying is not that at the end of the I don't know the analysis you did, it's not that you had that 377.
Yeah. Okay. Let me put it this way. When we did this analysis in the lab, like you see all these targets. On target, you see alpha to Berlin, you see CRZ, you see play and all. So there were different um, Excel files generated from the lab, raw files from analysis from laboratory analysis that was presented. So I joined these files in R. That I use some functions to collate all the data into a single file. Then that was now what I now saved in Excel as this analysis 2.csv. So I joined the files into one file because it's easy to our work can work with large data. So you can easily sort out, get what you want, tell R to remove these ones, analyze just this subset. So that is just it. I don't know if that's me.
Okay, thank you.
Okay. But what I wanted to describe another thing, which is about training data. Because I remember the work I tried to analyze, the one on brain data, where there was each column had maybe the value for cerebellum, value for the metal concentration data, where each column had different data for cerebellum, for brainstem, for cerebrum. So I kind of modify the data to be longer, such that there will be only one column for all of them. But rather, there now be an additional column for cerebellum. So there's another way to modify data to become very, very long. So I prefer working with R that way. I believe we might get to that someday.
Oh, okay.
Okay. So let's go back to our tutorial 1. Okay, so we are now in line 63. So this is just to show you what the negation sign can do. So of course we know okay, I don't know if I've told you that in R you can also run a command by selecting it, so that R will only run what was selected. So it will not, because if you not select anyone, R will run the entire line. But now let's say I want to run only the command true. If I run only true, I will run true and come out as true. So now you can see I've just run true, came out true. But now if I tell R, give me opposite of true, now say that it bring out false. So this just tells you what the negation command can do to negate it. So if I ask R, give me the negation of false to be true. So and then this is also another way of telling R, to bring up this command instead of having to modify it so that this will now have the negation sign. So you can also tell R like this, and it will still run the command. You put the negation sign outside and put what you want it to analyze opposites in brackets. So that's all I can describe about logical operations at this basic level. But with this, you can now understand bigger commands as time goes by. So any other questions so far on logical operations? Okay, so let's move to string operations. So string operations, I'm thinking of how best to teach it, because string operations make more sense when you are looking at genetic data. But I don't know, I thought I shouldn't go so deep.
When you are looking at what data? Sorry.
Genetic data, like DNA sequences, protein sequences,
Okay.
stuff like that. That's where, because those are strings. Now you have A T C C C G G T T T. So that's where you bring operations. Make more sense in our own basis as by medical scientists. But just to give you a basic understanding of it, to store string data in R, you must use this quotation marks. Like I can decide to run just this alone. Of course, R will print this. This is literal exam, as you can see. Now I'm decided to save it into an object called AA. I run it and be saved into an object called AA, which is here under values right here. And then this ncar is a function that asks R to count the number of characters. Since I've already said this object as AA, so this command now asks R, what is the number of characters in this thing? So if I now ask R, so this means 15. Of course, space is also a character. So if you count this to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So it's 15 characters that is there. So R does that for you. And then this is the cat command. So this is like to concatenate. You can use this to join different words and even to also paragraph to write text in R. So if you run this command, okay, it says A not found. Okay. I passed an object A, which was not stored. So maybe let's give A a meaning for R. So I'm writing this command in the console. So let's say good boys and girls. So I've now saved it. So if I now run this command, if I say run, so you can see what is printed. this is that, and number of alumni is, this, I understand this expression, \9 as paragraphing. So it's paragraphs at that point, and then the comma tells R that these are separate objects. So this is our first line of string text. Then okay, it starts with AA first type, which is this, then comma this. The comma separates the different text strings. Then this shows paragraphing, and the same thing, I believe. So that is just using this cat concatenation function to handle string R. So that's what I feel like we just talk about this big string operation in R. Maybe with time, we look into the genetic data and what we can do with it. So any comments or questions on this before we move to data structure? Okay, so coming to data structure. So remember in the first class we had where I told you about our structures, our data structures, we have vectors like we have vectors, we have data frame, we have lists. So the ones we've been doing so far are vectors. That's why they are stored below as values. So these are vectors, single line, stuff like this. These are vectors in R. Now, if you now go higher to some higher structures like the data frame. So now in line 76, we want to create an object called DBB, and this DBB will be a data frame, and it will have column names like this word here, name is the column. Okay, to better understand this, let me open the one we did before. Okay, the GR1, which we created. Okay, I think I closed it. So this is the GR1. If I open the GR1, so for this GR1, these are the columns, okay, and these are the rows, like 4, 5, 6, 7, 8. These are rows. Now all these well, flower, target, content, sample, these are all columns. You can also call these rows as cases and these columns as variables in R. So R understands them as variables and this as cases. Okay. So you can, this now is a typical data frame because it has rows and it has columns. That's what makes it a data frame. So it is two-dimensional because it has columns and it has rows. So to create a data frame, you must have equal number of values, like equal number of columns and equal number of rows. Like now, not really equal number. What I mean is, like now we want to create this object called DB, which would be the frame, and then with this name here to serve as a column, and this age here is another column. So, but they must have equal number of rows, so that there won't be anyone that is missing in R. That's why inside name we have Dave, Chris, Ahmed, and inside age we have 18, 29. So let's run this command so that you see what I mean. I've saved this data for me to an object called BBB. So
sorry, I have a question. We just
okay, go ahead. All right.
So in a situation where, which sometimes happens, you have a set of data and a variable is missing. So let's say, for example, in this case, maybe at the beginning, so let's say you're working with data at different days. You're working with data for different days. Maybe you're taking rectal temperature. So for day 1, you had all your animals. Excuse me. So you had maybe 8. But by the time you got to like day 15, it now became 6. if you wanted to work with that kind of data, would R still work with it?
Definitely. Yeah, this issue only comes up when you want to input your data in R. Usually, such data is organized in spreadsheets, maybe in Excel. So you can easily load that data in R, and R recognize those ones as missing values. So R can work with that perfectly. So, but this is for those who want to key in the data in R, which most times is not really available, but it's good for us to know it. Because there will be times when you want to create some data frames as you code. Just know that there must be equal number of rows. You can even create, an empty field in R. Like you put a null, like you can decide to just put comma, two commas. I recognize that's not that nobody as an empty value. So, but it must be equal. Let's say now, for instance, now, if I remove Chris, for instance, now, and I want to run this command, let's see, and I click run. So you see, R made me an error message that's, something is wrong. They are not equal. So, but I may decide to just come here and put a second comma. You can see no space, doesn't matter. I'll just run this command. Okay, R still didn't recognize it, so something has to be there. I may just put just two apostrophe and I run it, so R accepts it. So this shows that it is empty. But I think for numbers, let me remove this and run this. Okay, so there has to be something here. Then if I run this, okay, R accepts this. So there has to be something that indicates something is empty. That's by just using a double apostrophe without anything inside. R accepts that as an empty or missing value. So let's return this to how it was before. All right. So now let's run this so that this will return to R's memory. So now if I decide to now run BBB and see what it's like. So we can see this is what comes up. So Dave has this age as 18, Chris 22, Ahmed has 19. So that is what, so we created this data frame in R. So that's how it is. Then so we can decide to also create a list. So a list is similar to that frame, but it's a bit more accommodating, like in data frames, you can only have one type of data in each column. Take for instance now, if I remove Chris and put 87, and I run this, okay, it ran. Let me check this. I'm surprised it's run. Okay. Because R usually does not allow let me see. Okay, this has run as well. Okay. So the data frames usually, okay, I think I've just learned this too. I used to know that or think that data frames are very strict in that it only allows one type of data in each column. But I've seen it can allow different types of data in each column. So let's return. So but list, one thing about list is that lists can allow, like you can save a data frame in a list. So you can even save several data frames in one list. So a list can accommodate much more. But you can't have two data frames in one data frame, unlike list where you can have many objects, also many data types in it. So in a list, you can save a vector, you can save a data frame, you can save even other lists, you can save lists inside a list as well. So let's run this, for instance. Let's run CCC. And then let's now load CCC. So you see how list arranges things. It arranges them separately. So it brought out name as a different thing, age as a different thing. Now I can decide to save BBB also in this list. So now I can decide to also come here, type comma BBB. Then I run this. Then I can now decide to run my CCC. So you can see, let me expand this. So you can see under this CC, we have our name, have our age, we have this title 3 as our data frame. So list accommodates much more. Now there are times when you will need this. Okay, now in practical terms, like our GR1, it is a typical data frame where where you can put the data in a data frame and work with it in R in any way that you wish. And then for list, list may be useful when you want to work with a lot of data, and maybe let's say you want to save it in an Excel file. So such that maybe maybe each one is a data frame. Let me see if I have one. I think I should have. I think it should be in biochemical analysis newer. Okay, good. So in this lines of code, now I developed this object called assets as a list, okay, where I read different Excel files into it. Let me expand this so that you can see it better. Now, I developed this object called assay as a list, and I saved GSH as the first item in the list, which it will save this. I use this read Excel command, which saves this part of work. And here now I can specify the Excel file, and then where on in the worksheets. I also specify the worksheet, and then where the worksheets that are should just extract and save this JSX. So I save this. It's still from the same file, all those so new. I see they're all those so new, and then but in different worksheets that I told how to extract and save in different places. And then I now did some analysis, some modifications in each of them. Like I use this na.omit, which is like telling R to remove every line that has missing values. I think later we'll get to that. So I did that for all of them. And then here I now told R to also to remove anyone that has above certain values. So I like now I use this to remove outliers. Maybe what like line 19. So I use this command to remove outliers in these specific ones. Okay. Then I did other ones. So but now the thing that after I did all these analysis on them, I now told R to now save that list into an Excel file, which I titled results2.slsx using this command. So that's where we see lists become useful, where you can, instead of having separate files for different things, you can put them all in one Excel file. So we save them all as a list. As you create new ones, you add it to a list. As the list is the list is can be as long as you want. You know, R is very big. That's why I said R is a small file. What we do with it determines how big it can be. So I use it to do a lot of analysis and then save it in the list. And I attach the list until get the number I want. After R, okay, save this as a file in this location in my computer. And I will save it. And it is such that each object will now be as a worksheet in Excel. I hope you understand by worksheets because in Excel I'm not using Excel. I'm not using spreadsheets language. So each object will now have its own separate worksheet in the Excel file. So that's where lists can become useful. So now that means that each list has several data frames in this case. So you see where list and data frames come to play, where you can store a data frame in a list, and later you can now fill them all in one file, so that you can later use them as you deem fit. So okay, in this one, okay, so if we run this DDD, and then we now want to check what is in it. Let me select the DDD and run it. So that is it as it appears. Now we go to factors. Now factors is also a kind of is a type of vector because these are all vectors. So you can use C to join different strings, into a column or into a vector. So like if I decide to run just this alone, okay, if I run this, so you can see R brings them out. Let me remove this because this will block our view. So and then when I decide to save this into an object called name. So R has run it. Now factors is just a way of arranging it. Sometimes you may have very big data. Let's take for instance now this our GR1, where there is a lot of them. And let's say looking at this place called sample, for instance. Let's say you did some analysis and R may bring usually R brings out your results in alphabetical order. But maybe you want it to follow another order that you want. Maybe we bring out GM first, then HF and F. So that's where factor comes in R. So in factor, you tell R how you want it ordered. That's where factors come in. So so now, okay, here I can see I generated 3 vectors called name, gender, and marital. They are now created in that frame where I now, called in those objects to form the. So I can start to just select them all at once and run. So I don't need one after the other. So I press on it and it has run without errors. So I can now call up the DF. So this is the data frame that we have just created. And then I can now decide to create another. I now want to recode this gender, become a factor, so that male will come before female. So if I run this, then if I now run this gender, it brings me the level that male comes before female. Then okay, let's run the data frame again. Male, female. This gets important when we draw graphs. Let me look for an example. It will show in the table. Let me look for a graph where I used factor. Okay, like here now, I factored this A, B, C, D to MTP into the various groups so that they'll be so that this one will come before the other. Um, I would like to draw a graph without the factor defined and then one where the factor is defined so that you will get it. Let me see group 2. Okay. Let's see. I think I should have this already saved. Good. All right. Just to see what was used. So let me check this just to see. This is just to see. And all right. Let me run this graph and see what will come up. Okay, something has come up, but I don't think if you see it. Are you seeing any graph? I doubt. Are you guys seeing any graph? No. So let me. Okay, if you're seeing a graph like big enough or just small on the right hand side.
We're seeing raw cycle,
No,
D,
on the right hand
sex,
side.
female. It's not really looking like graph. Maybe we are not seeing everything.
Okay. Yeah, I know why. Um, I mean,
Maybe you should collapse the environment. Maybe we
yes.
can.
I'll have to let me share my full screen. I was sharing only the R screen. Okay. So let me run this file, this command. Just so D, just so C. Okay. So this is a scattergram. It's a rough one. So, but because I've already defined the factors to follow this pattern, this one will come first before this. But if I fail to define it under this group 2, um, let's say how do I let me look at how I'll get the to leave the factor. Okay, the command I wrote here was it would use the results in group column to fill this up. So it like a new grouping. Thinking of a way to make it easier to understand. By chemical analysis, okay, okay, I did the same here. Sorry, this is taking time to make understand this factor. I'm looking for the easiest way out Oh, okay, I may have to recode some of this to make it make sense. But just to put it in a simple way, um, if I hadn't uh, done the factor, I will arrange this alphabetically such that half one will be first, half two will be next, and it will be done alphabetically, then followed by control. But by using the factor, factor will make R obey the factor command and leave its alphabetical pattern. That's what the factor does. Sorry, to recode this will take time. That's why I'm thinking if there is any other way I could make it faster, but I can't think of any. And I think it's time already, 4:32. Um, but I think we are almost done with this. So the rest of them, this is just to view internal structures. Like this class, I don't even find any object called class. Have you defined class? So um maybe let me call this class. Then I run this line. So then I come here and ask R what is the structure of class. So I'll thinking that R is a character. So this character means this is R means character. If I ask, okay, let think I already have marital, then if I ask R what is part of marital, so tell me that the class is character. So class is used to ask R to define the type of object it is. What is to ask R my 101 to define the structure of the object. Then the type of, if I ask R type of character, I also ask R what's the mode. It tells me of DF. DF is it writes it as list. Let me see. Then what's the mode of DF? Let's write it at least. This one is a bit confusing now for me, but this is a data frame and not a list. I don't know why R is saying this, but if I say class of DF, class of DF is a data frame. So, but mode is saying list. Again, I have to find out more about that. Oh, okay. I think we are as good as done with this one. Then, so just class type of is used to ask R to define what object it is that is there. Then, okay, this now have to combine that frame. Let's quickly run this. If I should run this and then also run these gears, then I now ask R. Let me just use this. Let me not save it so that it will be faster for us to view on the console. If I ask R to column bind, so this is column bind. Then if I ask R to row bind, that is the arrow bind. So this is the arrow bind. So if we look at these two, so sorry, am I too fast?
Actually, in a way, yes. But I've told myself I'll just go back and watch the videos.
Okay, okay.
Yeah.
Sorry about that.
You are.
The time is I didn't want to go beyond 1 hour. It wasn't how other agreements. So this is C bind. Okay. So we first of all ran this line. So here we created a data frame called boys. We ran this line of code where we created two columns, name and age. And the name has these three names, the age has these three ages. So that is the boys. And if we remember, okay, if I write boys now and type it, so this is the boys. Remember, this is it. So, and if I type girls now, I've already set this, so this is what comes out. So I created two data frames using these two lines of code, and this is the boys own, this is the girls own. Now, this is the what I remember I telling people that when someone asked question earlier about how I got such a long table. So it was from different tables that I joined. So I used the rbind function to join. So if I want to join these two different data frames, I will use the rbind boys, comma girls. So the boys will be above, the girls will be below. So that is what happened here. You can see Dave, Chris Hamed, this one's here, came here. And then the Angel Absat Bookie came below it as the next one now. So that's how I did a row bind. So that I joined them. So to only
Sorry,
display
FYI.
the two
So if
columns.
you say bind
Okay.
girls, boys, it will put girls first.
Yes, okay. So let's try that. If I not say R bind girls, boys. So you can see the girls will come first. The boys will now come below.
Oh, okay, please, this is abnormal. Can you make boys first?
Okay.
What's
So
your problem? What exactly is all of your problem?
so for column bind increases the number of columns but retains the number of your rows. So this one you do not put the columns side by side. It depends on how you want to join your tables. So you can see the boys will come first for the girl because that was what I did. So I can also decide to also do a column bind. Then I can now say girls, boys. So these are ways where you can join data frame depending on what you want to do. Remember, I told you I joined mine. Uh, I don't know if where I did that, if I can find it where I did the row bind because I use more of row binds. Oh, good. Right here, you can see in my to create my drosod object. I row bound gr1 and gr2. Let me expand this so you understand the command I put forward here. So remember gr1, I told R to remove every row that has FCT under the sample column. And this is also another function and function. And also every row or every case that has MCT in the sample column of this object, so this. Then I now create another object gr2, I tell R to only allow rows where the sample column is only FCT and the sample column is also MCT. So this will be smaller than this one. So let's run this so that you also have a feel of it. If I should run this, okay, D is not even there. Okay, I first created D using this command. Okay, from C. So we have to first run this for us to now run this. Well, I think I have a GR1, GR2. For C. So that you won't have to be creating so many. Okay, so this is C. Good. So this will save all the whole stress. So arrow bound GR1 and GR2. Good. This is it. So if I run this GR2, you can see. If I want to run just GR2 alone, you can see it has come up. So it's just only 10 rows. So I thought I would give me only those that have MCT and FCT and it has brought this up. But if I should have run this, of course, the other one is bigger. GR1, GR1 is bigger. So you can see our GR1. So but R will only bring up the first 160 and then the rest to tell that transmitted the rest. But if I want to see them all, I'll use the V command so that it will come up on my script. I hope I'm not speaking so many jargons. So, but this row bind will now join GR1 and GR2 into one file because there are things that I needed to do separately for both of them. That was why I had to first separate them, and then I ran these commands, and then so anyway, just to make you have a feel of it. So I had this um where is Brosso B? Let me bring up Brosso B so that you understand it. So this is my Brosso B. Okay. So for my Brosso B, under the sample, okay, under sample, you can see these are all coded. So because the M here refers to male, and this F here refers to female, and this A refers to a group, and B refers to another group, as if it refers to another group, and MCT is male control, and FT is female control. So I needed to use different commands because here now I can usually tell R, look at this table under this row sample. The second letter of every thing there, if it is M, return male. If it is F, return female. Well, that wouldn't work for this because these ones are trailing letters. So that was why I had to divide it into two. So and I this one into GR1, this one into GR2. Yeah, and I told it that okay, create a new group where um for GR1 a new column called group, and then remove the first alphabet. That's what this one tells me, and then this one remove the for the sex, remove the second letter. Then for the GR2, when we have FCT, I now told R for this group, remove the second and third letters, and for the sex, remove only the first one. And then I told it that for this for on line 16, this command here tells it that if the if this previous one is M, return male. Otherwise, return female. I know I may be thinking this may be too advanced, but I don't know. Those who may know Excel may understand what I'm saying, but it's just what I did. But that's how you can use this R bind. So after it, I now brought them back together to now have my dissociate. Well, with time you understand it, or later when you go through this video, I believe you get to understand where you can use this arrow bind feature to join file after you have put them apart and do some things and then bring them back before you now do your main analysis. That's why our DOSOC here now has the sex well defined and the groups well defined. If you may recall, I removed the first alphabet A, that's why it's A here, and then B, only the B came out here as B. Then later I now use another code to tell it that anyone that is A, use replace A with MTP1, which is what I did here where I recorded it. So this line of command now created this column called group 2, where A will be this and B will be that, as you can see under this Dosso C. So you can see the group 2, here, what defined. So I'll follow my command and did as I instructed it. So I think that should be all. We've really gone way beyond our time. Any questions so far or comments? I hope this is not too much. Please, let me hear from you.
Yeah, okay. Actually, I really enjoyed today's class because maybe because I like the way you show us the application, even though it's complex, but at least one is saying that, okay, these are the basic. It tells you that by the time you now have a data and you want to analyze, so you will now be coming back and applying them. So I'm happy to see the application because I have been waiting for this actually. Thank you.
All right. Thank you, Dr. Gill, for that. Okay. Any other one? If not,
Um,
okay, Dr. James.
yes, sir. Thank you so much for today's class, sir. Uh, Although me, I'll not lie, it was a bit complex and I was lost at a point, but then that's why we can always go back to the video. So, but I just want to confirm, or should I say, ask about something. You you mentioned the function omit. I think you showed us at a point, and then um, earlier in the class you told us about the usage of the logical function not equal to. So I think their function was almost the same thing. So I just wanted to confirm if we can use the two of them like interchangeably. I think when you were explaining that logical function, you used it to remove um, uh, those that have FCT and MCT. I think that was the explanation used for it. So I just want to add that can we at that same point use dot omit to remove those um those should I call them data now that we don't want in those columns.
All right. That question. In fact, this afternoon I started preparing the next script. I'm not yet finished it. This is just I'm just starting the other script that we use for our software classes. And I tried to start use. I remember I use this omit. So omit and negation, they might be similar, but they're not exactly the same thing. Uh, omit, na.omit is an R function used to remove missing values. But negation means that you must define what you want R to negate. So if you want R, like now where I use the omit function here, so I define what I want R to omit. So that to omit anyone that is not FCT, and anyone that is not MCT. So the negation has to be, you must specify what you're negating. But in omission is already predefined. It's you're removing those that have missing values. So that's the difference between them. So for instance, now in this, okay, yeah, go ahead. Okay. So like now, for instance, in this new script I'm trying to develop, which I'll send to the group for the next class. Okay, there is R has as I see we are going ahead of this class, but R has some preloaded data sets. Okay, let's take for instance now air quality. If I run air quality, this is the air quality data that is in R. So it has some missing values. Anywhere you see NA like here and 7, it means the data is missing. So and you can see this has 153 rows, from 1 to 153. Now, uh, let's view this. What I want to explain now is it's better you view it in the script. So if I tell to view air quality, so it comes up here. Okay, so we see them all now. Now, I may now decide to tell R, like now I can see it has 153 rows and 6 columns. Okay, I can see all these ones N N A are missing values. So if I now tell R to remove any line that has any values, I can decide to no now I want to now run a function within a function. So I'm now making it a bit more complex. I'll now run the dot omit function inside the view function. Now I'm now saying view na dot omit open brackets equality, and I must I must have 2 brackets outside. One will close for the view, one will close for the now dot omit. Now if I run this code, you can see now we have 111 entries. Remember that here is 153. So here now it has removed. Like now, if you can recall under this equality, you can see that number 5 has missing values. Number 5, number 6, 10, and 11. Now, if you now come here now, you can see there's no 5, there's no 6, there's no 11. R has removed it. So that is where you can use the now dot omit. So it removes anyone with missing values. So that's also a way you can deal with missing values. So, but for the negation, you have to specify. You can even start to code it. You can tell R, you can use the negation to tell R remove one missing value. That one you use another code for it. You can even tell R to remove rows where maybe the wind is less than 8. So when I can even run that code, I can say view air quality, then I'll use the square brackets air quality. I'll now say air quality dollar. I hope we're not getting lost. So I'll now say air quality dollar. I think we said wind. I say air quality wind. What we want is to remove those that are less than 8. So remove those less than 8. There are many ways to say it. So to do that, I'll have to say put minus sign here because I want to remove air quality wind less than 8. Then I must put a comma. Why? Because when you use square brackets, you must specify a row and a column. So I'll define the row using this. So, but for the column, and without writing anything there, it means I will break out everything. Okay. So let's see if this will run. Good, it has run. So we can see okay, air quality wind less than 8 to remove. Is this correct? Wind less than 8. The air quality, that's air quality dot wind less than 8. I think I may have made some errors in the command. Let me see. Air quality view, air quality wind less than 8. Wind. I think I need to write another command. And let's quit. This should be here. Okay, that's it. I think, am I correct? To remove those less than 8. Good. That is so yeah, it worked here now. So I think I didn't write the full correct command. So it can reduce. So there is nothing here that is less than 8. That wind is less than 8. So I didn't use the which command to enforce it. What which does is that it tells R the position of something. Okay, it draws attention to what the which command does. Let's look at the original data now. For instance, I may want to ask R, okay, uh, which position can I find solar R equal to 90? Okay, that's let me pass that command now. Let's say which air quality dollar. What dollar does is if you want to go to a column in a data frame, so dollar helps you to go to a column. So let's say dollar solar.r equals to 190. So R tells you position of everywhere where solar R equals to 90. Remember that we have 153 rows here. So if I press enter, so you see here, it tells me that is in position 1 and position 112. You can see that it's here in position 1. Now let's go to 112 and see if R is correct. You can see 112. There it is. So that's what the which function does, which I didn't put in this command, which didn't give me what I wanted. So I don't know why R didn't find this as an error, but I know sometimes this works for strings, but it didn't work in this aspect. But I know if with the strings it works even without the which, whether I use the which or not. So that's where I think going to the original question, I think what for James asked was about what was that again?
Using negation and this in interchangeable
Yeah, negation and
and omit in the omit.
ability. No, meet good. So that's where this can be used in R. So yeah, that is where R can come in useful.
All right, thank you, sir.
Yeah. So any other? Sorry, we're taking so much time today. So I think we have to come to an end. So thank you all for your time and see you next week.
Thank you for your time.
Thank you, Pro, for your time. This is becoming complex, but it is well.
Thank you so much, sir.